Welcome. This is a short tutorial about creating flickering lights in modules. So I'll just start it up, and it also deals with a few tips on how to make your module dark in the first place, so you can actually see your light. As you can see, this is the final result. Sorry about the sound. This is the final result. You can see it's a pretty nice flickering light. Looks scary. This module has some smoke by default, so that's lit up, very nice. And unlike the light in the template map, I think it's called, or the reference map, this one actually flickers. So I think it's pretty cool. Let's see how it's done. So we return to the SnapMap editor, and I'll start with showing you how I got this dark in the first place. It's a bit of a trick. Of course, we have an atmosphere to choose from. It's important that you go for dark and not for night, because if you go for night, you can see that is a very heavy post effect. So it dims all the lights, even our own light, which should be very bright, but it looks like shit, really. There are lots of problems like that with the modules, so eventually I found dark, which is not completely black, but it still has working lights. It doesn't do an awful lot to the lights, so that means that our own light that we add will look pretty good as well. However, the module is not this dark by default. You can see there is a player blocking volume at the top here, which is set to textured, and that actually blocks lights. In this module, we are lucky with this module, it has a single light source. There are modules that have lights to the side or that have special spotlights, and you can't easily block those, but this one is very easy to block. You can see what happens when I delete it. This is actually how much light there is in this module, and you can still see some shadows because I have a model there, a hanging light. So this is actually how light this module is, even when it's set to dark. But because I have added a player blocking volume, it becomes this dark by default. So if I would remove the light, now it's this dark, which is pretty nice. Okay, so let's get right into it. I like to put my logic in a separate module. It's just easier sometimes, especially if you have more lights that flicker, then you can just link all those lights to one logic chain instead of repeating the same logic chain indefinitely. So before showing off the one on the right, I'll show you the basic one. This is actually the one in the example map that you get with SnapMap, and it's very simple. This is a map object, and we use the event on map started, so that's triggered before you even spawn. So it's the first thing that happens. It's like on map load, it's a bit like that. And then we have a repeater object, and we say start the repeater object, and it sends a signal with an interval. They call it a delay between repeats, and here I set it to 0.4 seconds. Then we simply have two outputs that disable and enable the light. And you can just, if you press G, you choose unsignaled, you can go to the light, and then you can pick one of these. And all I did was, normally they appear here, I just drag them out to here. So that's all that you're seeing here. Now the clue is that these are both triggered at the same time. Yeah, so it starts at 0, it gives off a signal, and then it gives a signal at 0.4, and then it gives us a signal at 0.8, and then it gives a signal at 1.6. So both of these are triggered at the same time, but the nice thing is that this signal has its own properties when you press X. So you can enter a delay here, and the off signal has a delay of 0.2 seconds, and the on signal has no delay at all. So that means that the light gets turned on, and remember, before this is repeated, it will take 0.4 seconds. And halfway, because we put a value of 0.2 in here, the light will be turned off. So by the time the repeater triggers again, the light is off, and the signal will be given again to both of these. This one has no delay, so the light gets turned on, and halfway it gets turned off. So that's the basics of a strobing light, a very simple light. So we can see how that looks, and then you will see the difference with the flickering light. See, this works, but it's very, very mechanical. You know, maybe this is nice for machinery or something, but it could be better. It doesn't look like a broken light. It looks like a light from a machine. So how can we fix that? We can fix that by some logic magic, or node magic, or however you want to call it. So essentially, a lot here is the same. You know, we still have the off signal and the on signal, enable, disable, all of that is the same. However, you can see that here, instead of a simple value, it references a variable that I named random flicker. So that variable is right here. And what it is, it's called a float, or a decimal number. It has digits or decimals. It has decimals, so digits after the separation mark, however it's called, the dot. So it's more precise, and that is what we want, because we will work with small values. And the nice thing is that we can actually randomize this, and we do this by we create a variable, and we do that by going, I think it was to the right. Yep. Here we have whole numbers, integers, and here we have, they call it a number. Normally you would call it a float in programming. It's just more precise. So we can pick that, and we can place it, and then something interesting happens. When you create a variable once, you can use it wherever you want. So right now I already have a variable named random flicker. If I would place it here again, these two would be the same. If I would change the value here, this value would change as well, because it's in the name. It's a reference to the variable random flicker. So this is very powerful and very useful. You can make changes to a variable in different places because they reference the same object. But the first time you create a variable, what you do is you choose new. So it's its own thing. You can't always only pick an existing variable if you are certain that you want to have it, and otherwise you create a new one and you give it its own name. So once we have that, we can just signal it, and then we get a wide range of options, which is really cool. You know, we can set it to a specific number, we can add to it, subtract from it, multiply it, divide it. I think we have a modulo here. Yes, excellent. Min and max, it's awesome. But we also have randomize, and randomize is what we want. So I've chosen that, and that is what we have here on signaled. We want a random value assigned to this variable. So that's very cool. If you look here, I will look into the repeater first. I've changed this to 0.3. It's a little bit shorter. It's important to remember that value. And right here, I've set it to a min value and a max value, and this will make sense very soon. The minimal value is the shortest amount of time that I want the light to be on. If it's shorter than that, you get a very ugly stroboscopic effect. It's not very nice on the eyes, so that's why there's a min value. the max value is actually quite a bit larger than the interval of the repeater. And the reason for that is that the randomize function generates a value in between the min and the max value. And by extending the range and then later truncating it, I will show you what I mean with that in a second, I essentially guarantee that about half the time the value will be the max value. And that is what I want. If we go to the variable, you can see here a much more reasonable value. What you see here is it's almost the value of the interval of the repeater. It's not 0.3, it's actually 0.29, but the only reason for that is that I don't want it to overlap exactly, because that would mean that a light can be turned on and remain completely on, and it's just asking for buggy behavior. That's not something we want. So even though the randomizer can give a value of 0.5, it will always be truncated to 0.29. So that's great, but because it's higher here, we will get this value more often, and otherwise we would always get values in between these two equally, and now it's more biased to max out. So if we go to the off value and we look here, then you can see that that variable is linked. You can link variables. You can choose between a static value, which is just something you enter, you choose, and the variable by holding Control and then pressing X. And you can see I just swapped it. Now I can type a number, and in this case it's 0. And if I want to change this again, I can press Control and X, and I can choose one of the variables I have defined. If I would have defined more variables elsewhere in the level, they would be next to this variable, and I would be able to pick them. Just that I created this variable close to this logic chain doesn't mean I have to. It's a choice. But of course, we have one. We drive it, we randomize it, so we know that we want random flicker. We choose it, there it is, excellent. So what we have now is a randomized delay, and it's between a minimum value, so the light gets turned on and it will always be on for 0.1 seconds, always. That's the minimum value. But it could also be on for much longer. It could be on for as much as 0.29 seconds. So that's pretty much the full interval of the repeater. This means that a light can be on for longer than 0.3 seconds, and that is what we want. That is why it looks completely random, because of course there will be a dip, 0.29 is not the same as 0.3, so it will get turned off very, very quickly, but it's 1/100th of a second. You won't see it. It will just look like it stayed it stayed on while the repeater gave off its signal. So it sounds a little bit technical, but essentially, the chain is pretty much the same. It's just this chain. You just add a number, a float that you randomize every time the repeater triggers, and instead of entering a delay, you reference a variable. And the clue is here. You want to remember you have your repeater with a delay, and you want a minimum value. That's the minimum time that the light will be on. The max value essentially dictates how often the light will remain on over one cycle of the repeater. So instead of being on for 0.3 seconds at the max, entering a higher value here will make certain that it stays on often longer than 0.3 seconds. And then if you look in here, this is the min value, it's the same value, and the max value is just 1/100th of a second less than the interval of your repeater. So it's quite a bit of talk, but it's relatively simple, and the effect is very cool. So I hope you enjoyed this. I will give the ID in the video description, and if you have tips yourself, feel free to share them, make videos. Let's make cool maps with SnapMap together.